Welcome to TWIND webinar. So you are all, the participants are all unmuted. I believe you can all see the agenda for today. Will be 1.5 hours webinar. And we have all the speakers for today with us, and also José Cândido, who will be the moderator. So I will give the words to José. Welcome, José.
Thank you, Carolina. Good morning, everybody. Welcome to TWIND webinar on funding opportunities for offshore wind projects in Europe. The project is organizing a first of a series of webinars on offshore wind. This is part of our stakeholder engagement activities that we have foreseen for the project. We had expected to have in-person events organized, but due to this situation we're all living in with the pandemic, we decided to organize a series of short webinars with relevant topics in the offshore wind sector. So just a brief recapture of the agenda that we have for today. So basically, I will start by presenting very shortly what is the TWIND project as a project coordinator. Then I'll give a brief overview of our institution, WavEC Offshore Renewables. I'll pass then the word to my colleague Amorina Armayor to speak a bit about the funding opportunities in Portugal. Then we'll go through the different partners we have in the consortium so that they can speak a bit about their own institutions and the funding opportunities in their own countries. We'll have then a presentation by José Villate from TECNALIA on the first approach in the project to the funding options with a plan for funding applications. We had then a final session in which Germán Pérez, also from TECNALIA, will talk about funding mechanisms, in particular the European Green Deal that, as you know, is now open for calls. In the end, we'll have a session on questions and answers, a Q&A session, which I'll be also moderating. I'll ask you to type in the questions you may have in the chat window that you should see on your control panel. And if possible, introduce the name of the person towards you think the question should be directed. I have also to tell you that this webinar is being recorded. So the session is being recorded, and I need to inform you about this. So without further ado, I'll move on to my first presentation. Carolina, I'm not seeing here now the sharing option. Okay, yeah, thank you. Carolina, can you tell me if you're seeing my screen already?
Yes.
Okay, great. So as I said, the first presentation which I'll be giving will be on the TWIND project, a brief overview of the project. So the full name of the project is Twinning for an Offshore Wind Energy Partnership. This was a response to the Horizon 2020 widespread twinning call. It's in fact a coordination and support action. It's roughly, the total funding is roughly around 800,000 euros. The project kicked off in last July, July from 2019, and it's due to finish by the end of June 2022, although due to the pandemic also we're trying now to understand if we'll have an extension in the project. The challenge of the twinning actions is first and foremost to enhance networking activities between research institutions from a widening country and international leading counterparts at EU level, and this focus on a specific topic. At the same time, there is this goal of avoid crowding out effect by research-intensive institutions, which we see happening in a lot of the relevant fields across the main research areas. The scope, so twinning action has the goal to strengthen the defined fields of research in a university or research organization from the winding country. In this case, we're talking about WavEC Offshore Renewables from Portugal, and doing so by linking it to at least 2 international leading research institutions from at least 2 different member states or associated countries. And the goal is to enhance the science and technology capacity of the linked institutions, all of them, but of course with the main focus on the organization from the winding country, and also to help raising the research profile of the institution from the winding country and of course of its own staff. So going back specifically to the TWIND project, it's a small consortium of 4 partners. So WavEC Offshore Renewables, as I mentioned, it's the institution from the winding country, and as such we are the coordinators of the project. Then we have TECNALIA from Spain, Offshore Renewable Energy Catapult from the United Kingdom, and the Technical University of Delft from the Netherlands. In terms of the structure of the project, it is organized in 5 work packages with 2 typically operational work packages, 1 on coordination, project management, and 1 on dissemination and public outreach. And then 3 core work packages, each focused on a respective target group. So we have capacitation and networking, focused on the senior staff from the institutions, training and mentorship, focusing on the junior staff, and then stakeholder engagement, of course, focusing on stakeholders in the offshore wind project. We've seen these main vectors that you see spread out around this diagram. So basically supply chain development, promoting test sites, aligning interests, innovative thinking, skill development, capacity building, public awareness, promoting gender balance, and also interdisciplinary research. In terms of the research focus or the scientific focus, initially 3 pillars were identified, all based in the respective main expertises from the different institutions, so the leading institutions. So we have whole system digital twins of large offshore wind turbines. We have high fidelity computational modeling, add-ons for wind turbine blades, and also numerical modeling and validation for floating offshore wind turbines. Going back a bit to what are the main activities for the different target groups. So we have foreseen a series of activities for the senior staff, early stage researchers, and stakeholders, being these the 3 main target groups of the project. For senior staff, we have been organizing a few already, given the pandemic situation, as much as possible. So we've been organizing short-term staff exchanges, also expert visits for partnership building, and we've been organizing a series also of think tank meetings between the different senior staff. For early stage researchers, we have short courses, summer schools, and also visits to laboratories and test facilities. For the stakeholder target group, so we, as I mentioned, we have foreseen in-person workshops for engagement with the stakeholder community. Of course, now we have also the webinars, also roundtable discussions, and an educational program. So this basically, in a very short amount of time, is what the TWIND project is about. Now I will present briefly our institution, WavEC Offshore Renewables, which is, as I said, the coordinator of the project. As the institution from Portugal as a winding country in the field of offshore renewable energy. So we are located in Portugal, in Lisbon, precisely. We've been founded in 2003, initially focusing mostly on wave energy and slowly expanding to other offshore renewables and more recently to offshore aquaculture. You're still seeing my screen, correct?
Now we're seeing, but maybe you could show us the previous slides. I don't know if you had previous slides or not, or if this is the first one.
Yeah. Okay, this is the first
so everything
one, yeah.
is fine.
So basically, this is the first one. Okay. Yeah, if it disappears, please let me know. Okay. Okay, so as I said, so we were founded in 2003. We are formally an association with 7 associates from industry and academia. We have a multidisciplinary team of highly qualified people with background in different areas from engineering, economics, and biology to biology. The staff is the permanent staff is roughly 25 people, 7 of which are possibly around this number are PhDs. We work in close collaboration with universities, authorities, and industry. And we have extensive international partnerships, which I'll show a bit ahead. So as I mentioned, formally we are an association. We have currently 7 associates, and we're talking about companies from the energy industry and services sectors, but as well institutions of the national science and technology system. We focused our activity mostly on these 3 business areas. So marine renewable energies, which encompasses offshore wind, of course, but also wave energy and others. Also offshore aquaculture, which we see as a growing sector and which will be having a potential large growth in the near future. And also we provide a range of specialized technical and engineering solutions for different applications across the ocean economy. We have clients spread out all over the world, from utility scale companies to technology developers, universities, public authorities. We have, as I mentioned previously, a strong focus on the European research area. We've been involved to date in around 60 research and development and innovation projects, which amounts to roughly 11 million euros funding to date. Based on this, we built a strong partnership of more than 200 partners. And you see here a few of the projects we've been engaged in since our foundation until today, a few of which have been coordinated by ourselves. In terms of the services we can offer, they are spread out around our main core areas of expertise. I'm not going to go extensively through this list, but it focuses mostly on complex system engineering, instrumentation and data acquisition, environmental monitoring and impact assessment, logistics and infrastructure, site and project development. We have also some activities on training and also as well on strategy and policy advice. Apart from these services, we have been also engaged in the development of innovative products for specific needs. We have a few of our most outstanding developments illustrated here. We developed a cost-effective multi-parametric buoy. We also developed Simio Tracker, which is an autonomous underwater sensor which uses the magnetic field generated by power cables to power small systems and other applications. We have a robotic arm, which we call Kraken, which mimics the movements of the human arm with the same degrees of freedom. And we had our first spin-off, which is ProDrone, which is basically a company that works on inspection and analysis of wind turbines using drones, which are basically doing everything by their own without the need of specific intervention from the operator. I'll just give you a very brief list of the reference offshore wind services and products that we've been engaged with, and this is basically one slide. I summed up this in one slide. We've been engaged in the wind float project to support the demo project, the pilot project of the 2 megawatt turbine in Portugal. We also provided support to the tender of the Wind Float Atlantic project export cable. We've been also engaged in operation maintenance strategy development for an offshore wind farm in the Baltic Sea, working with ILF consulting engineers for a company in Poland. And we have developed also a few projects for the Carbon Trust in the UK in partnership with our partners LLC, London Offshore Consultants. And we worked on the infrastructure and logistical challenges for floating wind farms, on the offshore heavy lift maintenance at sites as against tow to port maintenance of offshore wind farms, and also on floating component exchange of large offshore operation and maintenance components of fixed foundation offshore wind farms. We've been also engaged in the Wind Float Atlantic to support the development of the farm in Portugal, 25 megawatts farm, as you may be aware of. And we also worked on the preliminary study of a wind turbine to supply energy to oil platform in Brazil. This is just a picture to show you our team. We're roughly still the same people with one or two differences. And I would like also to finish by promoting our annual seminar, which this year we decided to move it to a free online event. So I encourage you to find news in our website and apply to the seminar, which will be organized between the 9th and the 10th of December this year. So this is it for me. I would now pass the words to my colleague Amorina Armayor, which, as I mentioned, will speak a bit about the funding opportunities in Portugal for offshore winds. So Carolina, if you want to give...
Yes. Amorina has no control. Thank you.
Thank you, Carolina.
Can you see my
Amorina, yes. And now it's perfect. Thank you.
Okay, so give me a second. This one, the first one. So I will go. I want to explain all the opportunities we have to work here in Portugal. There are a lot, and it will take much more than 5 minutes. But I did want to show that, for example, when we are talking about funding opportunities, it's not only about a prototype regarding a turbine or regarding a platform. There's a platform called Portugal 2020 where you can apply to different kinds of funds. This is just an extract of some of the funding that has been already approved and is related to offshore technologies. And you can find funding from 40%, going from 40% to 85%, some coming from federal funds, others for the carbon fund, some amounts that are only 200,000 euros are going up to 30 million. And I would encourage you to check the website, and also, I mean, we can help you analyze which are the funding options for each case. But there are a lot of different activities that are part of the supply chain of offshore wind, and they're not only regarding a turbine or a platform or a fixed structure. These are just some of the examples. There are also a lot of challenges, especially for startups. EDP has a program to engage with startups. Accione has another one as well. GALP has just started a new innovation hub here in Lisbon. And these type of challenges, which can go from using drones for operation maintenance, using AI for monitoring, using robots for underwater inspections, these challenges keep changing all the time. There are new challenges as well, and though before, usually especially engineering companies were close to bringing new ideas into their own side. Now they're opening to engaging, especially with startups, and that could also be another way to fund your idea. Here in Portugal, we also have, though they're not official test sites, we have Viana and we have Aguçadora. And the Blue Gift project, for example, already includes Aguçadora as a test site. So if you are looking for funding to test your devices here, that could also be an option. We also have testing facilities in laboratories for WAVE and for WIND. So if you contact us, we can give you more information or where to find the or how to get into that testing. This was just an example to show you the supply chain metrics we were building with the project, and we're still updating. We're working now on version 2. You can download it from the website, but we already had a lot of participation and it keeps increasing. But we tried to cover even a wide range of services, and we added an option for other services. And though at first it was surprising to see how many people actually added new services that weren't even on the list. So please don't be afraid to contact us or to look for funding in different areas. And that's it. I tried to keep it short. Okay, hope you liked our presentation.
Carolina.
Carolina?
So now I'll pass the word to, I'll pass the word now to Axelle Viré from Technical University of Delft, which will present her institution and give a broad overview of the panorama in the Netherlands. So maybe Carolina, you can give now access to Axelle to share a screen.
Yeah, she already has control. Just waiting to see her screen.
Yes, do you see the screen?
Yes, it's perfect.
Yeah, so welcome everyone. My name is Axelle Viré. I'm an assistant professor in the wind energy group at TU Delft. And so today I will talk a little bit about TU Delft and what we do, and also again show some opportunities for collaborations with us. So wind energy at TU Delft started a bit more than 40 years ago with two key people, Professor Gerard van Bussel and Professor Gijs van Kuik, and they both really started the activities here. In '99, Gijs van Kuik also founded what we call TWIND, which is the Delft University Wind Energy Institute, today led by Simon Watson. And this institute is not really a physical institute, but it's really a network of people working on wind energy at TU Delft. So that links different faculties on the campus, aerospace engineering, which is where the main wind energy group stands, mechanical engineering, civil engineering, electrical engineering, and then policy and management. And in addition to being a networking institute, it of course also sets the agenda on wind energy, both at TU Delft and also to some extent at national and international levels. So I'd like to show a little bit of what we do within the wind. So one key area for us historically also is really rotor aerodynamics and airfoil design. You might know that a lot of the DU airfoils are used in modern wind turbines. And so we do that using wind tunnel testing. We have a wide range of different facilities, and we also have a wide range of different numerical simulation tools, ranging from low or medium fidelity to high fidelity CFD. So this is, for example, a snapshot on the left-hand side of a larger dissimulation of flow past a rotor model as an actuator line. And in the right-hand side, you see some testing we recently did with VGs and other types of add-ons. We also recently have established a group looking at aeroacoustics, so looking at noise impact for wind turbines and other applications. What we also look at is wind turbine foundations, both fixed and floating. Fixed foundation is mostly done with my colleagues at civil engineering. They look at design, but also at installation. Again, noise reduction, for example, is an important aspect. Integration with the soil properties. So we have experts there on that topic. We also look at floating platforms. And here again, you see some numerical results that we did on the OC6. So as part of the IEA task, comparing Navier-Stokes solutions with potential flow and experimental data for wave impacting on a semi-submersible. We, of course, look at wind farms. We have a strong group of researchers in mechanical engineering led by Professor Van Wingerden, looking at wind farm control and developing novel control methods for optimizing, for example, the power output of a farm. We also look at multidisciplinary design optimization, MDAO. We've done it so far for offshore wind farms, fixed offshore wind bottom-mounted turbines, and we are now starting to extend that framework to floating offshore wind farms. And my colleagues at electrical engineering, they look at things like grid integration and also to some extent the gearbox and nacelle and gearbox. Eventually, we have people looking at materials and sustainability, for example, manufacturing of large composite plates, structural health monitoring, damage detection, and recycling. And last but not least, we have also different people looking at emerging concepts. I list again here floating offshore wind, which might not be so emerging anymore, but we also have things like airborne wind energy. We have historically also a very strong group there. You see here on the picture a kite wing. So we have both numerical models, but also a prototype of a kite power system that we can actually fly and take measures from. And finally, I also list vertical axis wind turbines, which again are not very new, but are emerging again with the application to floating. So again, we have a few people looking into that. So this gives you in a few minutes all the different research areas of what we do at TU Delft. Now, in terms of opportunities for collaborations and in relation to funding, of course, I would like to present very briefly, three examples of projects that we do, in particular in collaboration with companies. The first one is an EU-funded project. It was recently granted, so it started last April, and it's called STEP for Wind. It's funded under the Marie Curie actions of the H2020 framework. And it is really what we call a European Industrial Doctorate Consortium, meaning that we have 10 PhD students as part of this project, which are really jointly supervised between academia and industry. I won't go into details of what the project covers. You see here that actually we are all focusing on different aspects of floating offshore wind. And you see on the left-hand side the beneficiaries. And this contains 3 universities, and we have 4 companies or research institutes. So these are the institutions that mainly host the researchers. Then we also have a set of associated partners, which are partners that can bring additional advice, perhaps additional secondments, so seconding, hosting the researchers for just a few months. And this list of associated partners is actually today growing, which is also nice to see. So in practice, when I say this is a really joint academic industry partnership, what I mean is that we really developed this project jointly between the 2 sectors. That means also that we recruited the early stage researchers jointly. We now started supervision jointly, and we will assess the PhD work jointly. Also, very practically, each PhD student spends 50% of their time in academia and 50% of their time in industry. So the project is only starting, but we really hope that by doing that and by working and supervising jointly, we will have a good transfer of knowledge and utilization from academia to industry. And it's also important to mention that this is, of course, these are PhD projects, so research projects, but training of these PhD students is also a key element of the project. So we will also organize a series of training events Again, some organized by industries, some organized by the academic institutions. So if you want to know more, I direct you to our website, and we also have a Twitter account. Another project that I would like to single out very quickly is a nationally funded project. That is funded by the Dutch Research Council, RVO, under a scheme called Renewable Energy, or Hernieuwbare Energie in Dutch. This was a smaller consortium made of three parties, so us as TU Delft, and then two companies based in the Netherlands. And the objective of the project was to really look at different types of add-ons to boost the performance of wind turbines. We looked at vortex generators. We looked at, for example, a slat here, which we looked at numerically and also experimentally. And the project is lasted for 3 years and it's actually ending this month. So we have a big set of data for different add-ons. And yeah, as I said, both numerical, wind tunnel, and also I should say on the actual turbine of 2B Energy. The last project I would like to very briefly mention is what I call a small-scale collaboration. This is also a nice way of collaborating with us. It's through master students. We've done that recently with Siemens Gamesa in The Hague, but we can also work with companies abroad. And that's, of course, a nice way of starting a collaboration, is to establish a master thesis project together. We did that, for example, on looking at vortex-induced vibrations for wind turbine towers. And the results were interesting enough that we could even publish this recently in Wind Energy Science. So again, this is a nice way of starting a collaboration, and perhaps that can lead to bigger proposal as a follow-up. So just to summarize, there is a range of funding opportunities that we can think of, both nationally. Then, of course, if you want to have funding, it's usually targeted more to Dutch companies, but we are also part of a number of large EU projects, being very practical, like the Crosswind Consortium that was granted this summer, or more academic schemes, perhaps with PhD students and Marie Curie actions, again, with the possibility to strongly interact with industries. I also would like to mention another scheme of the EU funding, which is the Future Emerging Technologies. It's quite a competitive call, but that really allows us to look at radically new technologies. And that, as companies, might be something that you don't want to do, on your own resources, but something that you can partner, for example, with us to get funding and then have the resources to look at something perhaps a little bit crazy, a little bit more long-term. So in short, there are, of course, as you know, annual calls. You know now what we do at TU Delft. If you have any interest or you see any use of collaborations with us, please feel free to contact me, and I can also direct you to the right person if it's not in my own field of research. Thank you.
Thank you, Axelle. I would like to remind all the attendees that you can type in your questions in the questions dashboard that you have on your control panels. Please don't forget to do so that you can have hopefully a lively Q&A session by the end of the webinar. I will now pass the word to Thomas Wildsmith, which will give an overview of Offshore Renewable Energy Catapult from UK, and also talk a bit about the different funding opportunities focused on the UK. So Tom, I give the word to you.
Thank you very much. I am just making sure I share the right screen. Can you see my presentation there, everyone?
We see it. Yeah, we can see it now. Yeah.
Perfect. Hi. So yeah, I'm Thomas Wildsmith.
Thomas, sorry, before you start, can you please close your team chat?
Yes,
on Teams, because we're seeing it. Thank you.
That's gone. Sorry about that. So hi everyone, I'm Thomas Wildsmith from the Offshore Renewable Energy Catapult. So I'm going to give you a quick introduction to the Catapult. First of all, I would like to sort of draw your attention to the Catapult network. So in the UK, we have 9 Catapult centres, and these are aimed at being world-leading centres to try and transform the UK's capability in innovation. And it's all around growth and innovation and helping businesses go from TRL 4, TRL 5 through to TRL 7, TRL 8. So it's really about that valley of death that a lot of innovation funding, such as Horizon 2020 funding, is there to support. So the Offshore Renewable Energy Catapult is very much focused on offshore renewable energy. So anything to do with wind, wave, or tidal energy, we're very interested in. We've got multiple sites now across the UK, as you can see on the map, alongside 3 research hubs, which are tied into 4 universities within the United Kingdom. I think it's worth pointing out that within that, we've also got a number now of centres of excellence. So we have a centre of excellence around floating offshore wind, which is based up in Scotland, but we'll cover, you know, any parties interested, and that's very much open to European collaborations too. We have a centre for excellence around operations and maintenance, which again is based in Hull, where the Siemens Gamesa site is, amongst others, and there's a lot of O&M coming out of the Grimsby, Hull area, that sort of greater Humberside region, and that's very much focused on some of the data analytics, operations and maintenance tasks that are going on, and how we can optimize them and look at reducing LCOE. So our main focus as a catapult is, I'd say there's twofold. So there's the focus on UK growth and helping UK companies, but I think secondly, we're very much interested in how can we drive cost reductions and growth innovation in offshore renewable technologies, and we do a lot around those spaces. So we try and look at creating value in the whole supply chain. So we work with the whole list, and I mentioned already some of the academic partners there, but we work with owner operators. So EDF is the example on this slide, but we have, you know, relationships with SSE, Vattenfall, Ørsted. We work a lot with OEMs and GE on the slide there. If you're not aware, we're currently testing GE's Halide X generator in our 15 megawatt powertrain test facility, and also their 107 meter blades in our blade test facility. So we've got world leading test facilities to go on top of this, but we do a huge amount going down the supply chain, and a lot of our attention is really focused, I'd say, in this SME and agile innovation space, and what we can do with companies in that space who, you know, sort of pre-commercial or looking into getting into that commercial space. How can we accelerate them that way? And a lot of it is looking at not just how the supply chain comes down, but how we can push technologies up. And we do a lot of interactions around that. So I mentioned our test and validation facilities. I think this is the sort of wow slide, and I think the Catapult does a lot more now than just testing, but it's worth highlighting what we have. So this is our facilities in Blythe, which are just outside Newcastle upon Tyne in the northeast. And you'll see some large buildings. So the large building here on the right, that's a 100+ meter blade test facility that's currently active, and the big building towards the back is our 15 megawatt powertrain. But working with smaller businesses, we also test blades up to 50 meters and powertrains down as low as sort of hundreds of kilowatts, and I've got an example of that later on. It's also worth pointing out we do a lot of testing around high voltage and materials, looking at cable failures and cable analysis and those aspects, and that's in this building on the bottom left. And we're currently in discussions to expand into doing a lot more around robotics and automated systems, and recognizing that this is a critical development space as we move forward. So I wanted to give a quick example of an R&D project that we've worked with. So I've picked Greenspur Wind, Greenspur Renewables. These are a UK SME, and they're looking very much at a next generation generator technology, which removes the need for rare earth metals. So very much looking at the sustainability side of offshore renewables. And, you know, while we're generating renewable energy, there's a lot of other issues around some of the materials we use and the recycling and access to some of those materials. So if we can get this technology proven and scaled to multi-megawatt, then this could lead to a significant number of jobs in the UK and across Europe, and that's where we're coming in. So this was supported by a grant from Innovate UK, who is the UK national funding body, and they came to us last year to do a series of tests with their 250 kilowatt generator. And more importantly, they're coming back in again this year, and they'll probably hopefully coming back in next year as they continue to scale and work with us. So we're very much now engaged with them and helping them develop their technology. As part of that, helping link them and engage them with end users and industry partners. So in terms of funding opportunities to work with the ORE Catapult, I've put one which is quite hot in terms of we've got a few weeks left. So there's the Marinette 2. This allows subsidized testing on several of our assets. This includes some of our dock facilities, that 1 megawatt powertrain I just talked about, some small scale blade testing, and our materials and high voltage labs. The reason I wanted to highlight this one is we can't work with you if you're in the UK. So non-UK companies are more than eligible to apply for this. And there's details on the website there, or more than happy to get in touch with myself and I'll provide more information. Looking closer to home, we have Innovate UK, which is part of the government funding stream. So they have a series of funding calls across the year. Now the work must be carried out in the United Kingdom. So if you're a non-UK based business but have some offices and some research capability in the UK, then you're more than welcome to apply for this, and we can provide steer on that. But it must be carried out in the UK. And again, it's aimed at that sort of technology readiness level of 4 to technology readiness level 6, that sort of valley of death. And up to 70% of your costs are generally covered by those grants. And then I suppose it's also worth highlighting some of the other opportunities that come up. So the Carbon Trust often have, through their offshore wind accelerator, have a range of calls, tender calls that come out. And we're very keen to engage on several of those projects if they come through and work with businesses from around Europe, around the globe. And there's also some accelerator programs that are currently active, and we have our own accelerator program called Launch Academy, which is coming to the end of its first year. So we have a national launch academy and we have a regional one based in the northeast of England. And again, although you need to have a UK presence, we're very interested to talk to businesses and see. And a lot of the launch academy programs that we're talking about here is really about how we get you engaged with the supply chain and looking at answering the questions that we're seeing coming in at the tier 1 and OEM and owner operator end. So thanks very much for listening. There's some general contact details there for the Catapult. Please do engage with us. Please do get in touch with myself if there's any questions or anything else I can help you with.
Thank you, Tom. We'll now have José Villate from TECNALIA, which will present TECNALIA. We'll give an overview of the company and also funding opportunities in Spain. And we'll also talk after that about TWIND's first approach to funding options and the project plan for funding applications. So, José Luis, I give the word to you now. And please, Carolina, allow.
Yeah, hello, good morning. Can you see my screen? Okay.
Yes.
Yes, yes.
So, thank you. Perfect. So, good afternoon, good morning. Thanks, José, for the introduction. My name is José Luis Villate. And I will merge the two presentations, so there is no separation between these next two presentations. First, some experience from TECNALIA about funding offshore wind projects and some indication about which type of opportunities are in Spain now for funding offshore wind, and also the first approach to funding option of the produced by the TWIND project. I'll say that I will merge both presentations because I wanted to introduce some concept of funding different TRL levels to talk about the situation in Spain. Okay? So first, let me start with a short introduction about TECNALIA and our activity in offshore renewables. TECNALIA is one of the leading R&D centers in Europe with around 1,500 experts working on 6 different sectors: advanced manufacturing, sustainable mobility, urban ecosystem, energy transition, health, and digital transformation. Our activity is oriented towards transforming technology into GDP to improve people's quality of life and create business opportunities. Within the energy transformation business, we cover from the renewable energy generation to the final energy use, including energy transport and distribution. We have also 2 key enable technologies. One is digitalization, that is a new trend for the reducing cost and improving energy in the energy system in global, and also materials for energy and environment. All of them trying to keep a neutral and a friendly integration in the ecosystem, in the environment. So going more in detail into offshore renewable energy, We work in three main sectors or applications. One is a fixed offshore wind turbine with a clear focus to reduce cost throughout innovations. The second, as Axelle said before, is not is an emerging, but more than emerging technology, is floating offshore wind turbines that we are seeing that are more and more used, and more projects on R&D projects on floating solution. And the third one is wave and tidal energy. This is just a summary, some figures about history in TECNALIA in offshore wind. We have more than 15 years of experience with a totaling 40 million euro of investing in different type of research projects on R&D. We have transferred 4 patents to the industry. We have contributed to different international committees, advisory groups, organization of events. We've collaborated with our regional government to define a marine energy strategy. And we have created two technologies, two new technology-based companies. One of them developing a wave energy converter that now is in 2018 was acquired by an industrial company, IDOM. So we completed the process of starting from a concept, developing some initial prototypes, low TRL, testing the device in different scales, and then transferring the technology to an industrial company. The second spin-off from TECNALIA is Nautilus Floating Solution. It's focused on floating offshore wind. We started this activity in 2010, and then around 2013 we created a new company with some industrial partners here in the Basque Country, and now we are trying to help this company to have the first demonstration project. And we have been very active in European projects. We have participated in 20 projects. We have led so far 5 projects in Horizon 2020, well, mixing FP7 and Horizon 2020. This is a summary of what our knowledge and how we try to apply our knowledge. So we have activities in couple analysis and multiphysical modeling. So it's usually our knowledge mainly around simulation and modeling, including experimental modeling, using now new techniques for data analytics and deep learning. And also we have some activities in system engineering and decision tool, creating knowledge and tools to help the decision making from companies or investors. And we support the testing of components for offshore application in real conditions. We have a new activity trying to generate digital twins of components for offshore applications to support life extension, operation, maintenance, and redesign. And this is more, let's say, traditional in our the last year. That is the design and optimization of offshore structures, covering the structure itself, foundation, mooring, umbilical cable, and so on. And we have been quite active generating new concepts and also helping others to evaluate new innovation for offshore renewables. I'm going to explain now some examples of R&D projects in which we have participated, covering different types of funding. The first one is a European project, Life 50 Plus, already finished. The main aim of this project was the qualification of innovative floating structure for 10 megawatt wind turbines. As I said, the project is already finished, and some important results are public, where advanced numerical model, tools for cost calculation and life cycle analysis, a methodology for risk assessment, and design recommended practices. So if you go to the website, you will find some public available reports and models. Within this project, I have to say also that the Nautilus concept was improved and was considering different wind turbines and sites. The second project is different, is ongoing, is funded by the regional government. in the Basque Country in Spain, in which a consortium of 10 industrial companies join force to develop integral solutions for foundations, towers, and other systems for big offshore wind turbines. So in this case, the leadership is from industrial companies and research organizations such as TECNALIA. We are subcontractor of the industrial partners trying to solve some specific aspects from the R&D with our R&D knowledge. The final aim is to improve the competitiveness of the project partners. So this is a regional funding to improve competitiveness, or usually SMEs, local SMEs. And they usually keep 100% of the intellectual property. So here the important aspect is what the companies want to develop, and based on new technologies, innovations. The third project, Mateo, is a pure research project, also funded by the regional government, by the Basque government, with the main aim of creating new knowledge for offshore wind based on new mathematical objects. So this is completely different project, is more science-based, is to solve some specific problems using science, using mathematics in this case. TECNALIA is leading this consortium with the participation of 3 departments of the University of the Basque Country and the Basque Center for Applied Mathematics. In this case, intellectual property is 100% owned by the research organizations, but with the objective to be transferred this IP to industrial companies in future projects. Usually, I mean higher TRL. So this is a pure research project, low TRL, quite low TRL, trying to solve some basic problems that in the future can be transferred to the 2 companies. And the fourth project is actually an investment. It's in a new laboratory that we call HARS Lab. It's an investment in a testing infrastructure. TECNALIA, in collaboration with several local companies and the support again of the Basque government, decided to use in-house funding. So it's a collaboration of industrial, following industrial interest, plus some support of the Basque government, but plus in-house funding to set up a new floating laboratory for experimentation and validation of material and components in a real offshore environment. This laboratory is in operation since September 2018, and we have provided a testing service for different companies and also research projects. We plan to install a new version of this lab next year with additional feature, and you can find more information in the harslab.eu website. So I'm going to move now, after presenting these examples of R&D projects, I would like to say some words about one of the first results of the TWIND project, an approach to funding option for offshore wind. This is a public report that you can find in the project, in the TWIND project website. These documents was produced some 1 year ago, more or less, and identifies first the typical funding mechanism. So has one section for the identification of typical funding mechanisms. The document is mainly oriented to opportunities in Portugal, because this project is mainly to support the development of offshore wind in Portugal. And finally, the third section is about case studies from other countries and in Portugal, and also conclusions and recommendations. In this webinar today, I would like to present 2 pieces of information of this report. The first one is a schematic representation of different types of funding, depending on the maturity of the TRL. Let's something that we are used to use, that is the TRL, the tenure readiness level. For very low TRLs, pure research is applicable usually with high rates of funding, but mainly for the academic world. I mentioned one project before, the Mateo project is this type of projects. When we increase in the TRL, applied research and the new development funds are used. Our experience in this case is this funding is better used, or has better results when it's addressed to industrial needs, to industrial companies, with the support of research organization. But we think that this applied research sometimes works better when it's led by the industry. Of course, again, with the support from research organization. For higher TRLs, also we will need demonstration and pilot projects and in real condition. And this can be a clear bottleneck in some countries, like I will explain later in Spain, because usually require high budgets to test real devices in real conditions. This is a critical step for entering new technologies into the market, and the combination of public and private funding is crucial in this case. When technologies are close to a commercial stage, innovation technologies still need some public support. So we are high in the scale of TRL, we are in the top level, but offshore wind still needs some public support that can take the form of incentives to the investment, for example, feed-in tariffs of contract for difference. But it's something that even after demonstration project and you have demonstrated technology can work, this is not the end of the public support. We need the sector offshore wind need additional support to create an ecosystem in which the projects can be funded. There is another type of funding that is the pre-commercial procurement that can be applicable to all of the TRL scale. Usually is more used by public organization in high TRLs, but I've seen some examples of in other sectors use pre-commercial procurement in low TRL when there is a critical aspect that the society needs to solve, usually connected, for example, for health aspects, that the government want to support to solve a problem for the whole society. In this case, usually there are different terms, but usually the public body supporting the technology development usually keep part of the whole of part of the intellectual property. And the second concept that I would like to introduce from this report I mentioned before is something that can be very simple, or you can see in the slide that is a very simple concept or representation, but it's something that we have learned in TECNALIA that is very important to understand when you apply for funding programs. There is usually a moment in which the public body is defining the funding program, so the funding conditions are not still defined. And in this case, you can try to accommodate or to define or to support the public body in the definition of this funding condition to be adapted to your needs. Usually, you can do that with participation in industrial association, research associations. Usually, the public bodies launch a public consultation in which they want to know the sector needs to define the better funding conditions. So this is the moment to trying to influence this funding program, this funding condition, and to bring this condition to your needs. But once the program is public, one is the funding conditions are official and cannot be changed, we have seen a lot of mistakes trying to adapt this funding condition to the project needs. And usually it's a critical mistake that some companies and research organizations made, that they take only part of the program condition, the funding condition, they adapt or this to the needs and trying to apply to this program, covering partially the funding requirements and so on. So our experience said that once the program is published and the conditions are set, you have to adapt your needs. You have to adapt your programs to fully cover, to respond 100% to the funding conditions. Is the indication that all in the consortium we have applied to different type of public funding. We want to bring Probably you know already this, but if not, take into account that you cannot accommodate the funding condition to your needs when the program is public. You can try to do it before in the step before. So, and this my final slide today is about what is happening in Spain. I have to say that we are living a transition moment, mainly connected to the definition of the new energy and climate plan in Spain. So these funding opportunities in Spain is more an explanation of what is happening, or what our views of, in general terms, connected to the different TRS that I have explained before, what is happening in Spain. So for pure research and basic science, let's say low TRLs, as I explained before, there are some transversal funding programs. There are no specific opportunities for offshore wind. And these opportunities are mainly for universities and research centers, sometimes in collaboration with industrial partners, but usually industrial partners, they get very low funding rates. So this is mainly oriented to research organization and universities. But you have to compete with other sectors. So in this case, this is not a green light because there are no specific. We would like to see more specific funding in Spain for in general offshore renewable, or just renewable energy, because mainly all of the programs are for completely covering all of the technologies and sectors. The second level, I think, is better covered in Spain, in particular in some regions of Spain, that is the applied research and technology development, these medium TRLs. There are several programs, and sometimes they are focused on some specific sector, for example, renewable energy. So there, I would say that, of course, the situation can improve, but there are programs both at national level and regional level, and typically a mix of consortium of public and research centers and industrial companies. Talking about demonstration and pilot projects, here is almost a red light. So we don't have this type of funding now in place in Spain, but I would like to be a bit positive, because the new national energy and climate plans, we hope that can bring this type of funding. Actually, there are different organizations trying to lobby the government, the national government, to include some specific programs to support pilot projects for offshore renewables. And in Spain, mainly focused on floating solutions. So this is something that we hope to see that can change. And the final stage, that is more the support to commercial or this project that are technologically close to the commercial solution. It seems that the new market support to renewables energy in Spain will be through auctions. There is a debate now if auctions should be technology neutral or not. Offshore wind will need specific measurements and specific auctions if this is the mechanism, because offshore wind cannot compete with, for example, solar energy in Spain. And if we want offshore wind projects in Spain, we will need specific support. First, to support the demonstration project, and then other funding mechanisms, for example, support to investment, pre-commercial procurement, and why not warranty funds, and specific auction for offshore wind. Why not to learn from a European mechanism like the Innovation Fund? We would like to have in Spain an Innovation Fund. I cannot bring more information from Spain because, as I said, we are in a transitional moment, and I hope that the new energy and climate plan will open the door to specific funding for offshore wind. This is all for my side. Thank you very much for your attention, and I will be happy to take any question at the end of the webinar.
Thank you, José Luis, for the very comprehensive presentation. And yeah, I reinforce what José Luis said. Please type in your questions. I can see we still have no questions on the question tab, so please don't be shy to type in your questions. And now, so we're a bit behind the schedule, but I think we can make up for that. So now I'll pass the words to Germán Pérez, also from TECNALIA, which will tell us a bit about the recently opened Green Deal. So the word is to you, Germán.
Hello, good morning. I think you can now see my screen, do you?
Correct, yes.
Yes, it's perfect.
Okay, first of all, I apologize if you hear some noise outside, hooters, firecrackers. I'm afraid there's a strike or something like that in a company close to us. So I hope you can still hear me clearly. Good morning, everybody. My name is Germán Pérez. I work with José Luis Villate in the offshore renewable energy area with TECNALIA. I'm the project manager for offshore wind project, bottom fixed and floating, mainly floating. And I will try to give you some highlights on the Green Deal call, specifically on the offshore renewables topic, which is more related to TWIND activity. The call was published on Thursday, 18 September. Sorry, I will move the slide. Okay. The call was published a couple of weeks ago, and I had the chance to attend the info days organized by the European Commission in the framework of the European Research and Innovation Days. So I'm going to give you some interpretation of the text based on the on the feedback we got from the project officer Matthijs Soet, who was in charge also of writing the topic. In the agenda, I'm starting with an overview of the Green Deal call with some background. I will summarize some areas and topics of the call, but I will focus on the main of the LCGD 2.1, which is innovative land-based and offshore renewable energy technologies. And as TWIND is about offshore wind, I will review the text highlighting the main parts of the subtopic, always in mind with preparing a good proposal. To introduce the Green Deal call, I have included some text from the European Commission, which provides some background and some ideas on the objectives and the focus of the Green Deal. First point is about the budget and the framework. Is part of the H2020 program and has a 1 billion budget only under the Green Deal call. It's focused on responding to the climate crisis and accelerate the solution to that crisis. And the aim is to support research and development initiative with the goal, the final goal, to make Europe climate neutral by 2050. So we are talking about R&D projects to develop and demonstrate technologies which, from the European Commission point of view, will be the key to help in the consecution of those ambitious objectives. In the last months, the EU gave us the reference that some 450 gigawatts of offshore wind, bottom fixed and floating, would be necessary by 2050 to accomplish with the renewables integration required to keep the global warming below 1.5 degrees Celsius. So bottom and fixed floating technologies in different sea basins will be necessary to accomplish this ambitious target. As for other work programs in the implementation of the R&D project, the EU expects tangible results and in the short term, which is challenging for the proposals and the project, and of course aligned with the Green Deal priorities, which I'm summarizing in the next slides. Finally, I want to highlight that the implementation of innovative ways to engage with civil society is one of the objectives of the Green Deal call. You will see this message, this one, and the environmental issues in all the text of the call, in different parts of the text of the call. As mentioned before, Green Deal call is part of the H2020 work program, 2018-2020, with 3 cross-cutting activities, being the last one, the building a low carbon climate resilient future. which is the Green Deal call, is the last one published, as mentioned before, 2 weeks ago. This is a common question in the info days. As part of H2020 program, UK companies have the same rights as for previous call. So UK companies are eligible, both as partners of a consortium or even leading a consortium. In this slide, I have highlighted the goal of the general goal of the Green Deal call. It's common for all the areas and topics. We can see in the text that the focus is on R&D activities to support environmental, social, and economic transformation to fight against the climate change. Here, the Commission introduced the COVID-19 crisis, supporting the idea that the renewables can be a way to stop the climate change and at the same time being an instrument to help with the EU's recovery after this health and economic crisis. The program not only expects proposals to demonstrate technologies and support the path, the way to commercialization, but also to get social engagement to make European citizens part of this technology transformation. Again, the message of social engagement with the technology development. The call is organized is broken down into 8 principal areas, each one comprising 1 to 3 different thematic topics, and 2 horizontal supporting areas on knowledge system, including research infrastructures, and citizen engagement. Again, you can see that citizen engagement is an important part of the whole Green Deal with a specific topics on that. This doesn't mean that the socioeconomic aspects doesn't have to be considered in a proposal. Every single proposal has to consider socioeconomic aspects. Okay? I will provide you just a very brief summary on the different areas and topics. We will focus, of course, in the second one in clean, affordable, and secure energy. Actually, in the innovative land-based and offshore renewable energy technologies and their integration into the energy system. We have other topics like the demonstration of a 100 megawatt electrolyzer, partnership with Africa to accelerate the green transition in that continent. Area 3 is focused on circular economy, while Area 4 is about efficient buildings. There are areas and topics on smart mobility, work on green ports and airports, food from farm to fork, restoring biodiversity and ecosystems, zero pollutions, and some others. Finally, these 2 horizontal areas, the supporting areas, include topics about research infrastructures, digital twin of the ocean, and 3 topics to empower citizens for transition towards a climate neutral, sustainable Europe. The idea is to make civil society part of the technology transformation expected by 2050. After the introduction of the Green Deal and the summary of the areas and topics, we will focus on innovative land-based and offshore renewable energy technologies and their integration into the energy system as part of Area 2, which is clean, affordable, and secure energy. The challenge is to develop and demonstrate technologies. And, in the subtopic of offshore renewables, the demonstration is crucial. That will be key to helping the transition to a climate neutral Europe by 2050. Here, onshore and offshore wind will be key, but also the integration of different mature technologies into the energy system. The topic is split into 2 subtopics, one about land-based renewables and the other about offshore renewables. Land-based technology subtopic is about district heating and cooling. Is not so focused on developing new renewable energy technologies, but on taking advantage of mature technologies to get the best of the whole energy production by combining different highly efficient energy sources. As mentioned before, TWIND is about offshore wind. So in the next slide, I will review the text of the second subtopic. We will start with the challenges. The proposal should address the demonstration at sea of power generation system integrated in the power system. It means that the systems must not only be installed, manufactured and installed, but also grid connected and operated for at least a couple of years. The solutions must demonstrate the cost efficiency. This is common, I guess, for all the topics and subtopics in the call, while being environmental friendly. This is another aspect which is repeated in the text in several parts. The environmental impact measures and monitoring is key for all this technology to demonstrate the feasibility of this technology, not only in terms of technical feasibility and cost feasibility, but also in terms of environmental impact. The call also put the focus on different sea basins. We can see here the mention to the Baltic Sea, North Sea, Atlantic area, Mediterranean Sea, Black Sea. Of course, the prototype and the demonstrator will be installed only in one place, but the potential for the deployment in other locations must be demonstrated and analyzed both in the proposal and then in the project. Finally, there's a reference to the use of the efficient use of material, especially if we have critical raw materials. Well, now we move to the technologies that the European Commission is looking for in the proposals. There are two of them. One is related to offshore renewable generation, and the other one is about grid infrastructure. For the offshore renewable energy generation, you can see that the topic is open to wind, wave, tidal, solar system, both on floating or bottom fixed structures. And we have here again the message that we have to consider the different subsea and meteorocean conditions. The other technology, which is part of the topic, is the grid integration. Grid integration with very clear focus on DC or AC/DC conversion and HVDC technologies and components. In this slide, you can see another key part of the topic, which is that it's clearly stated that at least one project on offshore renewables and one on grid infrastructure will be funded. It is opens the door also for the integration of both in a big project, big proposal involving both technology. But my feeling after the info day is that the Commission is looking for to fund two projects: one of offshore generation, offshore renewable generation, another one on grid infrastructure. At this part of the text, the call also opens the door to include Power-to-X battery storage system to maximize the use of the offshore energy generated. Again, my feeling is that this is not may also include, but it would be nice to have also these technologies. So I guess that the Commission is expecting proposals including also these technologies, especially Power-to-X. Finally, another remark is that the proposals could take advantage of ongoing projects in order to reduce cost, to save cost, and focus on the innovation. The integration of different technologies can also be considered, like wind plus wave, including floating solar or other technologies. As the project must be demonstrated at sea and reach TRL 7, which is full-scale systems demonstrating the real operating conditions, all these aspects mentioned here, industrialization, logistics, supply chain, must be considered, as well as permits and regulations, project finance, and marine spatial planning. Of course, again, environmental issues, public acceptance. I mean, everything you have to consider before deploying a prototype in the sea. We can see, again, the reference to environmental regulation and the request to present and implement an environmental monitoring plan for the project. Another key aspect of this subtopic is that the project has to include a go, no-go moment ahead of entering the deployment phase. This means that after a first period of the engineering, which could be 1 year, 1.5 years, the project has to include this go, no-go decision moment before the installation at sea. The Commission, supported by external consultants, will review all the information, all the permits, everything related to the financing, and of course the engineering, to decide if the project can continue or not. If the consortium fails to have all this information in place, the project could be stopped and the demonstration at sea cancelled. So it's very important to consider from the proposal stage permits, financing, and of course the part of engineering that will be part of the project development in the first 1 year, 1.5 years. Just a reminder that projects must bring the technologies and the interfaces, if you are combining different technologies into one platform or in separate platforms, to TRL 7. The expected budget for the proposals is 20 to 35 million, supporting the idea that the Commission is willing to fund 2 projects, maybe 3 maximum. The expected impact is highlighted in bold in the text. I think it's no surprises here. Have to demonstrate the potential of the technologies for the large-scale deployment of offshore renewables, while emphasizing the benefits for the environmental and the socioeconomic impact along the whole value chain. As for all the renewables and offshore wind in particular, cost reduction potential must also be demonstrated, and this must be done not only in the project but anticipated in the proposal. Total budget for the call is 68 million. We are talking about an innovation action, so the funding is 70% for industrial companies and 100% for non-profit institutions like universities, research institutes, and so on. Regarding deadlines, to present the proposal is 29th January 2021. Sorry, 26th January 2021. It's a one-stage proposal, and the expected duration of the project is 3 to 5 years. Considering that we have an engineering stage, the go-no-go decision, the manufacturing, and then the Commission expects 2 years of operation, I'd say that 5 years is more realistic than 3 years for the demonstration. And the Commission expects to sign the contract by August, September 2021, in 1 year time, more or less. And I just going to finish my presentation with a kind of a summary of the key highlights of the topic. The Commission is looking for projects with demonstration at sea of offshore renewable power generating systems, including manufacturing, installation, and operation, at least for 2 years. Grid infrastructure could be addressed together with offshore generation or in a separate project. I guess that the Commission is willing to fund 2 projects, one for generation, one for grid integration. Power to X battery storage systems, multifunctional platform may also be considered. I think it's a good point to have a good evaluation to include some of these technologies. The go, no-go moment ahead of the deployment stage, and of course consider marine spatial planning issues, environmental issues, public acceptance, and socioeconomic impact. And finally, the project, just another reminder, the project should bring the demonstrated technologies to TRL 7, and the budget for each project should be between 20 to 35 million, you know, this is just a reference, could go to higher budgets if you can justify very well. And deadline 26 January 2021. And this is all from my side. Thank you for your attention, and we are open for your questions.
Thank you very much, Germán. We have still 5 minutes for questions. We have one question, at least. Let me check. It's from José. Thank you for your question. So the question is, what opportunities are currently available for private funding, and what projects are seeking private financing at the moment? This is not directed towards anyone specifically. Maybe I think the best option would be to briefly run through all the countries, and I'll ask you to be brief about your comments. Amorina, is there something you want to say about this topic?
Hi, I'm not sure if you're a private investor and wants to fund a project specifically. Right now, to come here to Portugal, I don't have any particular projects. We do have contacts from other companies that are looking for funding, for example, for creating a modular dry dock that could be helpful for floating offshore wind and also for wave energy devices. I don't know if you can send us an email and we can arrange a call to discuss any specifics that you're looking for.
Thank you, Amorina. Tom, is there something you want to comment about this?
Again, it will depend on what you're looking to invest into. There's plenty of opportunities at the moment for private funding into actual deployment of wind farms. In terms of technology development, there's a vast number of small, medium enterprises who will be looking to secure private funding to take them to the next stages. And again, if that's what you're interested in, do get in touch and we can start to link you up with some of the businesses that we're aware of.
Thank you, Tom. Axelle, something you want to comment?
Yeah, a little bit along the same lines. I mean, as a university, we can also work with co-funding of researchers. It could be PhD, could be something else. So if companies are willing to put some money, and then sometimes depending on the amounts, and that's up to discussion, but the university then can put, you know, also some money in. So it's not tied to a specific funding or project. It's just the university topping up the amount so that we can really cover a researcher. And there are some calls where you can, if you provide a little bit of money, then you can also get, so that's still related to public funding, but then you kind of put something in yourself, so you have also a bit more flexibility there.
Thank you, Axelle. So from TECNALIA, maybe José Luis, you want to?
Yeah. Just to add that depending on the risk that the private investor is able to assume or is willing to assume, because of course there are offshore wind is emerging sector with a lot of opportunity to invest in new projects. Let's say new deployment of offshore wind turbines. But this is usually for big investors that they want to take the risk. Probably is not very high, but there are risks in terms of the permitting and so on. But there are also a lot of technologies around offshore wind. Could be companies developing new floating solutions, for example, or new sensor or new software-based technologies for services for offshore wind. I think there are plenty of companies, but usually in low TRL. So maybe the level of investment is lower, but the risk higher because you are entering in a low TRL. So there's I would say there is a big range of a wide range of opportunities for funding offshore wind. And the important thing I'd say is that there is a very growing sector with a lot of expectation, maybe to duplicate the power installed in Europe in the next in this decade from now to till 2030. So it's a sector with a lot of opportunities for investment.
Thank you. There was a final comment from José, just saying that he was thinking more about large projects with, like Windfalls Atlantic. Maybe we can take this up as a wake of the webinar, and maybe we can get in contact with José, or you can get in contact with us. So we have time for one last question, which is directed to Germán. So it's from Federico Freire. Thank you for your question. From the open day on the Green Deal, do you think the Commission is more keen on offshore wind projects or wave energy also?
Well, I think that a project of some 20 to 35 million euros, which is the aim of the proposals that the Commission is looking for, I guess that wave could be a perfect complement to some type of bottom fixed wind or floating wind. I think the only waves could be difficult because you know the potential for wave energy is big, but the technology is not so mature. So I guess that a combination of both could be a good option. But I guess the focus should be in the offshore wind. Yeah.
Okay, thank you. Unfortunately, we're running out of time, so I think we need to close now. Just some two final comments. One, that we'll be circulating a questionnaire, I believe tomorrow, about the webinar, in which you'll be able to express your opinions and probably make some follow-up contacts, and also express your willingness to participate in a few of these opportunities that we've been talking here today. Also to say that, and Amorina, correct me if I'm wrong, the presentations will be shared on the website, so you can have access.
The slides and the webinar itself will be uploaded into the website in the next few days.
Okay. So I want to thank all the speakers. Thank you, all of you. Thank you, Carolina, and thank you all the attendees for being here. I hope this was interesting for you, and please stay tuned for our next webinars and our next developments. We'll be very happy to engage with you and to show you all the developments we have. Thank you very much, and bye-bye. See you next time.
Thank you, everyone. Bye.